students. We are going through Concept 3 notes today. This paper you should have in front of you with a little periodic table with some arrows on it. Make sure you're following along as we go through. So, to start, we did the inquiry activity. Now, periodic trends, these are specific patterns in the periodic table that make it possible to make predictions about an element's properties. So like we've been seeing with valence electrons, the periodic table is set up in a particular order. There is a pattern to it, and so we can also then predict what an element's going to be like based on where it's located. So you can see the arrows here, and we're going to talk through a few of these in a moment. A lot of these are explained by Coulomb's law, and just so you know what that is, it is as the atomic number increases, the nuclear attraction for electrons increases. So you have that positive part of the nucleus, and the negative electrons, they try to get pulled closer together. That magnet part is stronger. So the electrons are pulled in more tightly. So again, as atomic number goes up, the number of protons increases, and as the number of protons increases, the strength of that charge. So we have more and more positive things in the center in our nucleus, and that pull for the electrons is even stronger. And then that strength, sorry, my head's a little bit in the way, but you can still see it. The strength of the nuclear charge, then the force of attraction for the electrons gets stronger and stronger. That's why we talked about how the electrons on the furthest level outside are actually have the most energy because they're really far away from that strongly pulling magnet. We're going to talk about 3 periodic trends right here and then take a little break. First, atomic radius, so like how big, think about the radius of a circle, that space from the center to the outside, how big it is. So it increases from from right to left and then top to bottom. So it's 1/2 the distance between the nuclei of 2 identical atoms bonded together. It tends to increase as you move down a group, so down the periodic table. And then it also tends to increase as you move left in a period, okay? And that's because, again, as there are more protons, the electrons are pulled tighter together. And then as you move to the next row down, you're actually adding a whole nother level of electrons. So we're getting bigger and bigger the further down we go the period and the further from the right to the left. Okay, how reactive something is, how quickly will it react. And it tends to react in ways that get them to have that full energy levels like the noble gases, and so it wants to be stable and happy. And metals, their reactivity increases as you go down and to the left, and the non-metals as you move up and to the right. So you can see that trend here and here. And then the shielding effect, just so that you know what this is, we're on the back side now with reactivity. It's when electrons in the inner energy levels block the attraction of the nucleus to the valence electrons. That makes that the valence electrons are more loosely held, so they're not quite so tightly held. And this increases as you go down a group, and as the atomic size is increasing, because the bigger an atom is, the more the inside electrons kind of block the attraction of that nucleus, okay? The more the attractive force is blocked, the greater the shielding effect on the valence electrons, and they're more likely to react because it's easier for them to to be taken away and maybe put into a bond. And then electronegativity, finally here, this is a measure of the ability of an atom to bond. So it wants to attract electrons. So think electronegativity, like how much do they want the electrons? And the bigger the electronegativity, the more strongly they're going to attract electrons. So which elements do you think are most wanting to have those electrons? Which ones maybe have the smallest amount? With the noble gases, really have any electronegativity? Do they want any electrons? So it tends to increase as you go up a group, and then as you move right, because those ones are really close to having that noble gas configuration. They want to look like noble gases, so they really want those electrons. This is the symbol for the difference in electronegativity between 2 atoms. The greater the difference, the stronger the electrons are pulled in one direction. And we're going to see that if it is greater than 2, it's an ionic bond, usually metals and nonmetals. If it is less than 0.5, it's a covalent bond, so they're going to share. That means they both kind of have an equal amount of wanting those electrons. And then finally, if it's between those two, it's a polar covalent bond, and the electrons are unequally shared. All right, let's do some practice.